So welcome to the NanoPhotonics group at the Cavendish Laboratory. So my name's Professor Jeremy Baumberg. I'm a Professor of Nanophotonics here. So I've been here since 2008, but I originally started for 10 years in industry as I'm interested in what can you really do with new science. So I worked for several years in California with IBM trying to make dense magnetic storage with light, and also with Hitachi trying to make the fastest optical switches in the world. And now I create unusual ways for light to interact with matter, combining research on quantum, on biosensing, on optoelectronics and nanomachinery. So we're building the intelligent toilet and the optical nose to transform healthcare. So I'm looking for really great students for a number of these projects. So the aim of the research group here is to uncover completely new science, work on things that no one else is, by bringing many different disciplines together. That's what you need in nanoscience. So when we confine light down to atomic scales, you need to understand the optics of metals, as plasmonics and metamaterials is the name of that, and the chemistry of molecules, and the materials of nanoparticle surfaces, and the engineering of devices, and the biotechnology of sensing. So my aim is to empower early researchers to discover their creativity by ensuring they're never waiting for others to be able to get on with their own projects. And that's why self-assembly as a way of making nanoconstructs is so important, because it's cheap, it's scalable, and if you do it right, it's astonishingly robust at the nanoscale. And then you get to try so many different approaches, and it's so quick to change. So everyone in the group works in teams that loosely form and reform depending on what we're trying to do. So we work constantly with the unknown, so it's vital for students to build up an intuition of what physical processes might be going on and what they look like, so they can spot the aha moments in the lab. I always get people to try and sketch and cartoons on the nanoscale that actually reveals how much we don't know. We rebuild and build our experiments constantly, which gives people great experience in optics and data processing, but they also pick up many other skills from chemistry to machine learning. There's no paper lab books in the group, as I get people tablets to write and sketch on so we can all share and brainstorm ideas all the time. So whenever anybody in the group publishes a paper, they actually have to bake a cake for us all, but in the style of the paper. You can check out hundreds of our cakes on our website. And we try to go away for a summer school each year to get to know each other better and share ideas and aspirations, but also problems, and learn new things and compete in crazy challenges, try something scary, and develop our thoughts on career paths from alumni in the past to everything in the future. I'm always looking for people with a wide range of different science backgrounds, and often with some experience of and maybe addiction to the struggle of problem solving in a lab, so you know what you're getting into. My aim is to find really unusual budding scientists who'll thrive in this atmosphere and become the leaders of the future.
My name is Caleb, and I'm a second-year PhD student. I design and fabricate nanoscale structures which trap, enhance, and mix together light of different wavelengths resonantly.
My name's Lily. I'm a second-year PhD student, and my work looks at what happens when we put emitting molecules into some of our plasmonic cavities, so things like collective emission effects or cooling effects.
My name is Sarah. I'm a third-year PhD student, and I'm working on surface-enhanced Raman spectroscopy methods to detect bioanalytes in biofluids, such as urine.
Hi, I'm Ishan Lohia. I'm a second-year PhD student here at the Department of Physics, and I work on nanophotonics, and specifically photocatalysis at the nanoscale. And in my PhD, I've studied areas of spectroscopy, Raman spectroscopy specifically, nanoscale self-assembly, some electrochemistry, and the biggest has been optics and nano-optics.
So I've been exposed to a lot of chemistry here that I had never learned about in my undergraduate degree. But more importantly, I transitioned from mostly theoretical work to experimental physics, and I think my biggest area of development has been developing those practical, pragmatic skills which experiments demand. I love the collaborative culture that we have here. I think it's nice to be in a group where people build each other up and support each other, and there's always someone to go to for help. There's a diverse skill set that we can access, and that means that there's a solution to almost any problem that you could come across.
So I started with a master's in physics, and I've definitely done a lot of chemistry since I've been here, and kind of more optics building than I was ever doing before, but also like a lot of teaching and outreach stuff as well. I I think you very much have your own problem to work on, and you can get very in depth with that. And it's very nice to have that problem and learn more and see as you go along, but you're never alone. There is always someone with expertise to help you when you get a little bit stuck.
So I have a background in biochemistry and chemistry, so working in a group in physics was a little bit out of my comfort zone, but I had the opportunity to learn quite a lot in this group. So for example, I've learned, to align a laser, learned a lot of optics, learned a lot of physics for sure. I definitely enjoy the very supportive environment that the group cultivates. So you get to ask all sorts of questions, even the really silly ones, and it really encourages people to learn new things and to explore new areas.
What I like about the group is that we have great lab spaces and equipment, especially optics labs. We have really nice kit that's fun to play around with, so I really enjoy that part of my PhD. I also enjoy that the group is quite large, but there's a good sense of collaboration and kind of like small teamwork as well. So it doesn't always feel like a really good group. You have a lot of expertise to focus on from all the people that come through, but there's also a good sense of cohesion and collaboration. And then the last thing that I like specifically about our research topic in nano-optics and plasmonics is you get the chance to explore both fundamental physics and kind of science and research with a more applied goal as well. So you can uncover more physics and stuff in your experiments, or you can work towards making a device or some real-world application, and oftentimes you have the opportunity to do both at the same time.